So a little bit about us and how we've used Aurora in the past. SRP started using Aurora in 2014, primarily for budgeting purposes and for electric price forecast modeling, which means we were using the WEC database and also doing our own little system, two-zoned model. In 2017, when I was helping another consultant to use a different tool to do our reliability modeling, I decided Aurora could probably do this too. And so we dropped the same data into Aurora and used the risk functionality there. And we've been having a lot of fun doing reliability modeling in Aurora as well. That's expanded. I messed that up a little bit. That was 2018. 2017, we did an integrated resource plan. We don't have a regulatory requirement to do any integrated resource plans. We do them because we like our stakeholders and want to engage with our board. That was all totally serious. And so 2017, we used Aurora for that. All of the portfolios that we selected at that time were handed to us. So we said, let's go see what it looks like if we do a gas portfolio, or let's go see what it looks like if we retire all the coal. We weren't using the long-term capacity expansion functions in Aurora at the time. Now I'm going to skip to 2020. That's when we started playing with Aurora's long-term capabilities. We've had a lot of fun with that so far, and then SRP has been in a process of including integrated system planning in our future. We're going to talk a little bit about what that means in just a minute, but it's an evolution of the integrated resource planning concept. Okay, so this is the traditional view. We start out with a load forecast. I don't need to point, right? We start out with a load forecast. We work with others in the company to make sure that we identify the appropriate inputs. We figure out our portfolios, we do all sorts of simulations, we come up with costs and sustainability impacts, and then we produce all the metrics that are required for decision making. One of the outputs from that is, at least for SRP, was a list of strategic directions, and some at SRP have called it the 10 commandments of resource selection. So things like SRP will commit to reduce our coal generation by X% in this year, or we will have a carbon reduction of this percentage by 2035, and so forth. So that was the traditional path. Moving forward, we're doing integrated system planning. We had our transmission planning group and our distribution planning group and our customer programs groups. They were all kind of tangential to our integrated resource planning work. It's been described as a siloed process at SRP. And some have said that we kind of take our results in resource planning and we lob them over the wall. And then transmission planning gets to complain about all of the selections that we made because we didn't consider the costs on their work. I know that integrated resource planning traditionally has included some opportunities for customer programs, but similarly there were just limited interactions and opportunities to share data. And so moving forward, SRP has decided to pursue integrated system planning. The concept here is that all of the planning groups would work together as equals at a round table, and we would find opportunities to share and influence the processes that we have. There's, of course, plenty of stakeholder and elected official engagement. And it's a process that we've been engaged in for the last couple of years. We're hoping to finalize our integrated system plan by the end of the summer, which in Phoenix might mean December. We'll see. Okay, I did get a fun call from Energy Exemplar when they saw the topic and the description. I want to make it very clear that what SRP has selected as an integrated integrated system planning workflow is a little bit different from what they're offering with Plexos. And so with Plexos, they can do an integrated system plan in one package. It's a simultaneous nodal capacity expansion that includes transmission elements. That's not what we're talking about here. What we're talking about is an increased collaboration of inputs and results and making sure that we're talking together. So they asked me to add the word workflow to my presentation. So this is an integrated system planning workflow. However, it was sufficient for what SRP determined was appropriate for our needs and making sure that we're not being siloed. And this slide was at that request. We're going to move right on now. Okay. This is the picture and the map that we've been using with our stakeholders. You'll notice that there's a blue dot, yeah, with an R in it, and that's me and my group. We do resource-related stuff. And so there are inputs here, and there are like analysis projects, and then there's the results. All you need to know from this is that resource and transmission and distribution and customer programs, we all rely on each other a lot. This workflow is pretty engaged and involved. There's a whole team dedicated to making sure that we're talking with one another and that we're working well. And what we're going to talk about today are some areas that we thought were important for us to include in in our improvements to make sure that we were ready for this collaboration and this opportunity. So there are 5 areas. We're going to talk through each of these on a different slide, but they include reliability and making sure that we get effective load carrying capability curves represented in our capacity expansion selections, transmission and fuel pipelines, and determining how we can figure out some thresholds for investment that may or may not be justified being selected, renewable energy zones, customer programs, considering those and how we do our resource selection, and then informing operational considerations and making sure that we're not creating plans that are called the ivory tower and ignored by people that actually run the system. We think that while these were important for us in this process, if you're not doing integrated system planning, these are all opportunities that could be relevant in your integrated resource planning processes as well. So the first one is reliability. We've, as I mentioned before, beginning in 2017 or 18, whichever year that was, we've been doing risk modeling in Aurora, and we've expanded our capabilities there and also looking at other opportunities. But what we've come up with are ELCC curves, effective load carrying capability curves. And to do a brief definition, if you have 100 megawatts of growth in your load, that doesn't mean that you can serve it with 100 megawatts of anything. You can't add 100 megawatts of solar or 100 megawatts of batteries even necessarily, or even 100 megawatts of gas. You need to figure out how the resources can support the load growth that you see. And that's the effective load carrying capability of the resources that you have. Turns out if you get really excited about one technology and pursue just that one technology, the marginal additions are less valuable to you. And what we see here is a curve that demonstrates, it's sample data, but it demonstrates what we were seeing, where as you add more of a specific technology, it becomes less and less valuable. Aurora doesn't let you drop in a curve, but what it does let you do is have prerequisite resources. And so what we did was a tranched treatment, where the first tranche has a higher ELCC or peak credit in Aurora, and then once you've maximized that opportunity, you move on to the next tranche and so forth. And so this is a good representation of an ELCC curve. We do think there are more opportunities that we're exploring for how to include dynamic impacts, because if you add more of a different type of resource, it might allow you to take more credit for the ones you already had. But very valuable and a great opportunity, and something that wasn't very difficult to implement. And so at least with this simplified approach, it's something that can easily be dropped in Aurora and help improve your resource selection. It's really strange to mention ELCC and not stop for questions. So I'm going to just charge right on forward. We did also mess with, we played with dynamic peak credit. And you'll notice there's another logo on here. We weren't comfortable with it. It seemed like it was something that was strange and exciting. And so we had some partners that helped us with this. We talked with a consulting group who I learned from Charles's presentation. They're not in the room, so we can say whatever we want, but we won't. There's an opportunity for Aurora to do dynamic peak credit assignment. What that does, you tell it how many hours you care about, and it can be as low as 1 or as many as 8760, I think, but that would be exciting. We dropped in different levels of hours, 10 and 50, and different sorts of resources and different other different inputs, and said how much dynamic peak credit did Aurora actually say these different resources were worth. And you can kind of derive a peak credit curve. It's not really true ELCC, but it's interesting and useful. This is something that we're exploring further, but it's a great opportunity to make sure that you're considering interactive effects. So what we looked at before, you have the battery ELCC curve, for example. But if you add more solar, the battery ELCC curve probably should be bumped up. And there's no way to really, for us to get that in the tranche treatment. And this is something that we're playing with and exploring, and we think could be useful moving forward for us. Okay, there's not a good picture here. Sometimes you have to make a big choice before you can have, what I came up with here is there's a transmission line, and then there's a rainbow. There's a pot of gold at the end of the rainbow, and you got to get through the transmission line first. And so sometimes there's a resource that you really want, but there's some investments that you need to make sure that you get that. What we were determining was that we weren't really capturing all of this effectively. So we talked with our transmission planning folks. We had generic things out there, like if you build geothermal, you got to assume 200 miles of transmission. That must be I don't know, a couple $100 million. But it matters what you include. And so our integrated system planning conclusion here is just talk to your friends in transmission and make sure that you include everything. And sometimes break out of generic assumptions and use explicit opportunities to model things that you know about. So if you got old RFP data that helps you understand what transmission costs might be there or other costs, just make sure that those are in there. This one is a representation of how we did that. And renewable energy zones, and this concept isn't new to us. We don't take credit for it, but we do enjoy what it teaches us. So there may be resource opportunities that are geographically specified, and you maybe have many opportunities for how to build a specific technology, but it would depend on where you build it. And there may be different transmission or gas pipeline costs or some other costs that are relevant. And renewable energy zones are one way to get at that. So what we did, and don't read too much into zone here. This isn't how we represented zones necessarily in Aurora, but you could if you wanted to. We said that there was an upfront cost and other characteristics that might be different depending on where you build something. And depending on whether you choose to pursue one opportunity, it opens up other resources for you. What we did, Aurora doesn't allow you to choose transmission or gas pipeline necessarily, but what you can do is create something that's a resource that's a proxy for those things. And you can give it no peak credit, but it is kind of a threshold that you have to break through before the other opportunities are available. So you got the proxy resource. If Aurora selects that, then there are other resources that had that as a prerequisite. And you can just fly through that valueless but costful proxy resource, and then it opens up a world of options to you. I hope that this all makes sense. But this is a lot of fun. We were really excited about this. And those on my team who are here have done some testing on it, and we're really excited to implement some of these in our ongoing resource selection opportunities. This is kind of similar to the transmission thing, where the big learning here is that we got to talk. And so we have customer programs, and they do our energy efficiency and our demand response. And if you take it a little step further, pricing programs that can influence the shape of our load. These are opportunities that you can represent in capacity expansion, but when you talk to stakeholders about that and say, well, this is the realistic amount of demand response or energy efficiency or savings from time of use programs, I'll warn you that those discussions are pretty tense, because what we believe is realistic is, in their view, not significant. And so what we did instead, we did test dropping these into capacity expansion, and it is effective and useful. What we chose to do instead, because of those sort of political concerns, was to do a before and after, where we dropped in a marginal amount of each and said, well, the marginal value of this is the next 100 megawatts of whatever opportunity there is this much. And if we can get it for that cost, then we'll proceed without really answering the question about how much is available. So it's kind of a punt, but it's an opportunity that you could consider. We did make sure that we talked with all our customer programs groups and our pricing groups, so all of the costs and benefits of these are accurately represented. And finally, we talked a lot about, I mentioned that we don't want to be the ivory tower. So the worst case is that you produce a resource plan, and then your operators tell you chose the wrong technology, that's worthless. You can't build that. And we've had some of those discussions in the past. And so to come around, to make sure we're kind of mitigating that risk, we believe that the outputs from our Aurora runs are useful in determining how we have seen the models run the resources. When we take that data and drop it into some business intelligence software like Power BI, you can see how the resources are run and then have good visible opportunities to discuss what you're actually seeing. So our operators have seen the data. We have representatives of the team that's been collaborating with them as well in the room. And it's been really useful for us to know that we have insight and inputs from those that have to run the system that we're producing. So those are the 5 areas that we're working on. A few conclusions. While Aurora doesn't produce a comprehensive integrated system plan, we do think that there are a lot of learnings that it can influence, and we're excited for what we've been able to figure out so far. We do think that silos are a big concern in resource planning and something that we have the tools to help overcome. And some of those, I have a couple of key takeaways that I thought about. First is collaboration. We need to make sure to talk to everybody clearly and make sure that they're able to influence our inputs. We think that the proxy resources with no capacity credit but some costs are really valuable and beneficial. We do want to talk to customer programs and the distributed resource teams as well. And then we've taken a lot of shortcuts in the past because we're doing a 30-year plan and nobody looks at the outputs. It's become more important for us to make sure that the outputs are something that we're able to share and talk about with those that are looking at the detail at our company. I think that is all I have, so thank you.